Bismillah ar-Rahman ar-Rahim. Now we'll focus on studying motion with constant acceleration. Dear student, the motion not necessarily to be with constant acceleration, but we'll focus on this type of motion because it is easier to deal with. Let me start by reminding you of the definition of acceleration. Acceleration is the rate of a change of velocity, velocity with respect to time. And when we say that the acceleration is constant, so A is constant, what does it mean? This implies that the change of velocity is constant as we change the time. So the change of velocity as time it changes is equal to constant. Now, some students get confused with this statement. When we talk about constant acceleration, they sometimes get confused with motion with constant velocity. I think we can easily visualize the motion with constant velocity. Look at my motion now. We can consider this motion to be motion with constant velocity. As you can see, I keep moving with the same speed. But if I ask you, or you ask me to demonstrate motion with constant acceleration, it will be very difficult for me. Why? Because every second my velocity will be changing. Okay? So if I have v initial is equal to 0 and I have an acceleration of 2 meters per second or 2 meters per second square. This means when the time equals 1 second, my velocity will be 2 meters per second. When time equals 2 seconds, my velocity will be 4 meters per second. When the time equals 3 seconds, my velocity will be 6 meters per second. As you can see, this is not easy job to demonstrate in front of you. So please keep in mind that constant acceleration means constant change of the velocity. As you can see here, the velocity was 0 at time equals 0, but it became 2 meters per second, 4 meters per second, 6 meters per second. As you can see, the change in the velocity is constant and it is 2 meters per second square. Okay, this type of motion can be described by 5 equations of motion. Okay, so now I write the equations of motion with constant acceleration. There are 5 equations. They are explained in your textbook. The derivation is explained there. I will not repeat it here, but let us write them. Equation number 1 gives us the relationship between 4 physical quantities. The final velocity at any final time equals the initial velocity plus the acceleration multiplied by the time needed to this change from v initial to v final. Number 2, the equation says delta x equals v initial t plus 1/2 a t square. Third equation, v final square minus v initial square equals 2a delta x. While the fourth equation, delta x equals v initial plus v final divided by 2 multiplied by the time period. The fifth equation, delta x equals, it is similar to equation number 2, except that we replace v initial with v final time and we replace the plus sign with a minus sign, 1/2 a t square. The derivation is in the textbook. If you see these equations, we can recognize the following. Here we have 1, 2, 3, 4 physical quantities. And here also, equation number 2, we have 1, 2, 3, 4 physical quantities. If you notice, there is one missing quantity here, which is delta x. It is missing. If you look at the second equation, what is missing? We miss the fifth quantity, which is v final. In the third, what is missing is time. And here we miss the acceleration. And finally, we miss the initial velocity. So this is very important. We have 5 physical quantities. We have 5 equations. Each equation has 4 quantities and 1 is missing. So this helps us a lot when we solve problems related to motion with constant acceleration. If you are not given a certain physical quantity and you are not asked to find that physical quantity, so you have to search for the equation which that quantity is not present. For example, if you are given a question and in that question you are not given the time and you are not requested to find the time, so your choice should go to equation number 3. Of course, because you have 4 physical quantities in one equation, so to solve the equation, you should be given 3 unknowns and you solve for the 4th one. Dear student, you have to notice one thing. If you refer to your textbook or other textbooks in the library, sometimes they use V rather than V final. And some other textbooks would like to use V0 rather than VI. This is just a matter of convention. So our convention here is the initial, anything initial, we call it VI or XI. Anything final, we call it V final or X final, etc. Let me give you a hint about the directions. It's very important to focus about the direction of acceleration and the direction of the velocity. Sometimes the velocity of the object is to the right. Okay? Let me give you an example of your car. You are driving your car and moving forward. So your velocity is forward. And you are accelerating your car by pressing on the gasoline pedal. In this case, your acceleration is forward in the same direction as your velocity, which is also forward. This means that your speed will be increasing. So the speed increases, and we say that the motion is, or the object is accelerating. Object is accelerating. Object, which is the car in this case, is accelerating. So its speed is increasing. Let us have another example. Your car is moving forward. So the velocity is in this direction. Then all of a sudden you press on the brakes. Okay, so if you press on the brakes, this means the acceleration is now in the opposite direction. So if the velocity and the acceleration are in opposite directions, this means that the speed of the object, which is your car in this case, decreases. And we say that the object is decelerating. Decelerate. Another case, if the velocity is forward and the acceleration is equal to 0, in this case there is no acceleration, meaning that there is no change in the velocity, and this means that the speed is constant. So these are 3 cases, and we have to be always noticing this. If the velocity and acceleration are in the same direction, the object will be accelerating. If the velocity and acceleration are in opposite directions, the object will be decelerating. If the acceleration is equal to 0, the velocity will be constant. It is important to notice that the direction of motion is shown by the velocity. Okay, so here the object is moving forward. Here also the object is moving forward, regardless the direction of the acceleration. Okay, so the direction of motion is shown by the direction of the velocity, not the acceleration. That's it. Now we'll talk about a special case of motion with constant acceleration. So this is a special case. This special case is the free fall. Free fall. The motion of free fall is considered to be a special case of the motion with constant acceleration. What we mean by a free fall? Let me start by definition. Free fall motion is the motion under the influence of the gravitational force only. If the object is moving while the gravitational force is the only force acting on it, the motion under the influence of gravitational force only. So the only force acting on the object during the motion is the gravitational force. There is no air resistance, or there is some small air resistance, but it is negligible in some cases. There is no engine, for example, affecting the motion of the object. So this motion is called free fall. Okay, let me give you an example here. The motion of this pen, if I throw it, if I release it from my hand while moving like this motion we call it free fall. Why? Because the only force acting on this pen while moving is the gravitational force. So here the acceleration is constant. Okay, so acceleration in this case is constant and it has fixed known value. It is minus g, where g is 9.8 meter per second square. So notice that g is positive, but the acceleration is minus g. So the acceleration due to gravity is minus 9.8. What do we mean by acceleration is minus g? It means in every second the velocity will change by an amount of 9.8 meter per second in every second. Okay, so I gave you this example of releasing the pen from rest. So here v initial was equal to 0, and we consider this to be a free fall. Let me give you another example, and I would like to know whether it is a free fall or not. The same pen, but now I'll not release it where v initial equals 0. Now I'll give it a small push. I'll give it a push here. Can we consider this motion as a free fall? Think about it. Some of you might say that, oh, there is a push from my hand. It means that there is another force other than the gravitational force. But I want to draw your attention that after leaving my hand, after the object leaves my hand, if you look at it when it is here, the only force acting on it is the gravitational force. So it is indeed also a free fall. But what is the difference between this case, the second case, and the first case? You might notice that the only difference is that v initial is different. So I give it some v initial, and this v initial is downward. We say that it has some initial velocity, but here in the first example, it was released from rest, so v initial was equal to 0. Let us have another third example. The third example I want to ask you the same object, but now I'll throw it upward. I throw it like this, upward. After leaving my hand, the object was moving up. It has reached a highest point, then it came down again. Can we say that this motion is also free fall? If you think about it, it follows the same definition, the motion under the influence of the gravitational force only. But what is the difference between this third case, the first case, and the second case? Here we have my object started with V initial, and V initial here is upward. So it goes up, comes back to the same floor. So if the object is released from rest, V initial is 0, or you throw the object downward, so your initial velocity is downward. Finally, V initial is upward. So V initial is not 0, but here it is positive, here it is negative. All three cases are free fall. Let me give you a counterexample. When can we say that the motion of the object is not a free fall? Let me give you this example. You see this piece of paper. If I release it now from rest and let it move, we cannot consider this to be a free fall. Why? There is a gravitational force, yes, but we cannot ignore the air resistance in this case. So it is not correct to say that this is a free falling object. Okay, to describe this motion, the motion of a freely falling object, to describe it, we can use the same equations of motion, which we described earlier. But now, the acceleration has a fixed value, which is minus g. So I'll come to these 5 equations of motion, and I replace any acceleration with minus g. So here I have minus g. Here I have also minus g. Here also I'll remove a and replace it with minus g. Here I don't have acceleration, so this will be the same. And finally, this minus sign will be replaced with a plus sign, and this will be g. Another change, here we are talking about vertical motion. So it makes sense to replace delta x with delta y because the object is moving vertically. So I replace delta x with delta y. Here also I make it delta y, and this is delta y, and here the missing quantity is delta y. Okay, and here we have also delta y. So we'll use the same 5 equations of motion and with the same convention which we used. Let us now talk about the convention of signs. We'll talk about the signs for these physical quantities. It is very important when we solve problems related to motion in free fall to notice the following. The acceleration is always negative. Okay, and it has a fixed value. So A is minus G equals minus 9.8 meter per second square. So in all cases, in all situations, whether the object is moving down, moving up, or at the highest point, the acceleration during the free fall is minus 9.8 meter per second square. Okay? What about velocity? Velocity, our convention is that the velocity, if the object is moving upward or the object is ascending. What do you mean by the word ascending? Ascending means the object is moving upward, the velocity will be positive. But if the object is descending, moving downward, the velocity will be negative. This is our convention. And the velocity in free fall will be 0 momentarily at the highest point. At the highest point, if you would like to know what is the highest point reached by an object in free fall, you should equate its velocity to be 0. at that point. Finally, let us discuss the sign for delta y. Delta y is y final minus y initial. And depending on the value of y final, the vertical position finally, and the vertical position initially, we can have delta y positive, delta y might be negative, or even it might be equal to 0. Let me discuss this. If y final is greater than y initial, this will result in delta y which is greater than 0. But if y final less than y initial, this will result in delta y which is less than 0. And if the object starts the motion and ends the motion at the same vertical position, this means y final will be equal to y initial, and in this case delta y will be equal to 0. Let me explain this in drawing. When we have y final greater than y initial, y final less than y initial, or y final equals y initial. Let me explain it here on the side. For example, if I have here a table and you throw an object from here, so this is your y initial, and the object goes up, and finally it is present here. Okay, so this is y final. As you can see, y final is greater than y initial, and delta y in this case will be positive, greater than 0. Okay, if I start my motion the opposite, okay, this is the floor, and we have a table, and you throw your object from here upward, and it goes down here. So this is your initial vertical position. This is your final vertical position, which is lower than the initial position. In this case, y final is less than y initial, and we'll have delta y less than 0. The third case, this is your floor, and you throw the object from here. It goes up, then it comes back all the way to the initial position. So this is your y initial, this is your y final, which is the same as y initial, and we can say that delta y equals 0. Now I'll give you an example of motion in free fall. Let us assume that you are on the top of a building. So this is your building. Okay, this is the floor below the building, and you throw the object upward. Okay, so this is your object. You throw it with v initial. So at time t equal 0, your v initial is upward. This is why I write it as positive number, and I write it as 19.6 meter per second. And because it is set in free fall motion, this means the acceleration will be minus g, which is minus 9.8 meter per second square. Okay? What will happen to the velocity of this object 1 second later? So this was at time t equals 0. This is v initial. Okay? 1 second later, my object will be somewhere here. So this is time t equals 1 second. What will be the velocity here at this point? The velocity is still upward, but it will be less than 19.6. I have the velocity is upward while the acceleration is downward. So this is decelerating motion. So v here will be 9.8 meter per second less than the initial velocity. So this will turn out to be 9.8 meter per second. And as you notice here, the acceleration is still is minus 9.8 meter per second square. One more second, the velocity will be reduced again 9.8. So 9.8 minus 9.8, and v here will be equal to 0, and this is the time t equals 2 seconds. As you also know, the acceleration at that point is minus 9.8. Okay, so the acceleration also is minus 9.8 meter per second square. So at the highest point, the velocity is 0, and still the acceleration is minus 9.8. Some students might get confused and say, oh, the object is at rest momentarily there. It means the acceleration is also 0. But be careful. If the acceleration is 0, means that the velocity of the object will never change. What does it mean? It means the object will stay there hanging, and it will never come back. This is not the observed situation in real life. So in real life, we see objects go up, stop momentarily, then come back. So at the highest point, there is acceleration because there is a change in the velocity, and the object will come back. Alhamdulillah that this is the situation. Otherwise, if we throw anything upward, it will never come back down. 1 second later, so here we have the velocity is 0. 1 second later, there is a change of how much? Of 9.8. So my object will be at the same height. This is at t equals 3 seconds. Okay, the velocity now is downward, and it has the same velocity as that at time t equal 1 second. So the velocity here is minus 9.8 meter per second. It has the same magnitude, but in the downward direction. The acceleration, as you know, still constant, minus 9.8 meter per second square. Here the velocity is downward and the acceleration is downward. This means the motion is accelerating, or the object is in accelerating motion, and the speed will be increasing downward. 1 more second later, so my object will be here. When the time equals 4 seconds, its velocity is more and more downward, and the velocity here is increased with 9.8. So this is minus 19.6, which is the same as the initial velocity at the same initial vertical position, but now it is moving downward, and the acceleration is still minus 9.8 meter per second square. If my object continue moving, it will be 1 second later, it will be here, t equals 5 seconds. The velocity has increased more and more. So v here is minus 29.4 meter per second, and the acceleration is still minus 9.8 meter per second square. I hope that you noticed something, that I have drawn the distance traveled by my object in the first second large, but in the second second of flight, it has been reduced. Why is this? Why is this? Because my object average speed at the first second is more than the average speed in the second second. So my object was moving fast at the beginning, and now its speed has reduced, so it will travel less distance in the second second. Okay, so in the free falling motion, the object doesn't travel the same distances in the same amount of time. Okay, so this is the distance traveled in the first second, but that is a smaller distance traveled in the second second. Okay, and also you notice that the time of flight moving up from y initial, if this is my y initial, and the object moves to the highest point, it takes it 2 seconds to reach the highest point. In order to come back to the same level, it takes another 2 seconds. So 2 seconds moving up, 2 seconds moving down until it reaches the same initial height. But because here we have no obstacle, it will continue moving downward. I hope this explains different concepts about the free fall. Thank you.